with our day with the quote of Atharveda, which says, Rohito Divmaruhat Tapsa Tapasvi, which means ऊंचा वह उठता है जो तप करता है, तप किए बिना किसी को आत्मोन्नति नहीं हो सकती. In English, it says that he rises high who meditates. No one can be elevated without meditating. So here, as we are all are here for learning the new things like robotics and this new era. So all the best for and welcome you all in this second day of the FTP. So now I would like to call Ms. Tanya for the brief profile of Professor P.M. Pathak sir. Over to you, Tanya.
Thank you, ma'am. Now I would like to welcome Dr. P.M. Pathak, who is currently working as professor in Department of Mechanical and Engineering in Industrial Engineering, IIT Roorkee. He has BTech in Mechanical Engineering from NIT Calcutta in 1988. He has an MTech in Solid Mechanics and Design from IIT Kanpur, India. He is PhD in Space Robotics from Indian Institute of Kharagpur in 2005. He has more than 21 years of teaching experience as well as 5 years of industrial experience. His research interests are in robotics, dynamics, control, bond graphic modeling, and design. He has published several research papers in different national and international journals and conferences, and also published a book in Intelligent Mechatronic Systems, Modeling, Control, and Diagnosis. He has several research projects which are currently undergoing by him. He has received an award in Mechanic Member of Technical Committee for Multi-Body Dynamic by International Federation for the promotion of mechanics and machine science in 2011, and also a Best Paper Award in 4th International Conference on Integrated Modeling and Analysis in Applied Control and Automation in 2010. He is an editorial member and reviewer of different reputed national and international journals. He has many national and international collaborations like India South Korea Joint Network Center, DST India, and INRIA France, Universidad Nacional de Rosario, Argentina, Kyungpong National Universities, Daegu, South Korea. He is member in different professional bodies like member in the Robotics Society of India, life member in Association for Machine Mechanism, Indian the IFTOM, and American Society of Mechanical Engineers. Now, I would like to invite Professor P.M. Pathak, sir, to enlighten us with his knowledge. Over to you, sir. Uh, sir, are you there?
So please unmute yourself. Hello. Sir, are you able to hear us? Hello. Gajendra sir, I think some technical issue is there with the Pathak sir. So I think we will wait for a 1 or 2 minute.
Yes, yes, ma'am. What? So what?
Okay, sir. Okay. In the meantime, as soon as sir join, uh, please any one of you can volunteer and tell us the feedback of yesterday's class. Any one of you from the participants?
Ma'am, may I? This is Anupama Jain this side.
Yes, sure, ma'am.
All right. So yesterday we had two sessions based on robotics. The first one, yes, we understood that. Once again, we are focusing on the class 6 onward students. Second session, sorry, maybe I don't have that bent of mind, but I found it too technical. I do not know how I could explain that to my students who do not have that basic knowledge of whatever was being taught yesterday. So I request if we could have lesser technical issues in these remaining sessions, please.
Yes, sure, ma'am. We will try our best to cope up with the very best speakers of the world of or India. For that, we will try our best to enlighten the knowledge with you and share knowledge with you. So,
Thank you so much. But I
uh,
request, I would like to congratulate you for the efforts that you're making towards empowering these us, the CBSE teachers, with the emerging or the already emerged trends. Thank you very much for that effort. Thank you so much.
uh, thank you, ma'am. Thank you. Anyone else?
Yes, ma'am. Good morning. I'm Sheetal from FS.
Good morning, ma'am. Good morning.
Ma'am, you're doing a tremendous job helping us all out.
Thank you so much, ma'am. Thank you.
Thank you so much for the efforts. Just one small request, ma'am.
Yeah,
PPT
sure.
chat, if you could put it in the chat box frequently because of the networks, we just happen to come out of the meet itself and the link goes off. So if you could uh, uh, put the link like
Okay, ma'am. I get your point. I request the organizers to send it 2 to 3 times so that your problem will be resolved.
okay.
I think Pathak sir
Okay,
has
okay.
joined the meeting. Welcome you, sir.
Welcome you, sir.
I think some technical issues there, so we will wait for 1 or 2 minutes. So as soon as Sir join us, so in the meantime, can we take the, um, I mean, say, we can share our knowledge with one of you. If anyone want to share her experience in the robotics, can share. Any one of you from the participants. You can share his or her experience in the field of robotics so that everyone will be enlisted from. Sorry. Any one of you from the participants can share his or her experience with us.
Due to some technical problem,
Okay, sir. Okay. So, sir, can we take the feedback or take the like conversation? Can I continue with it? Okay, sir. Okay, thank you, sir. So, anyone you from the participants can please come up with your knowledge and experience with the robotics so that all of us will be enlightened with your knowledge. Any one of you. I think this is the golden time when you are able to share your knowledge with the participants of with the faculty members of all over India. So, if you are having, if you feel that you are able to spread the knowledge in the field of the robotics with your colleagues, so that you can. Okay, so I think so. No one is interested in that. So I can tell you the what exactly Indian government is doing in this regard. They are doing very good efforts in that area, so that every child who is growing in the schools and as they are learning very quickly with a fresh mind, so they are conducting. Indian government is doing very well in this field and providing very best platforms to learn the robotics and all the digital make us knowledgeable and which make us the I mean say which make us the knowledgeable for getting the and spreading the knowledge with the students with our childs, so that they can aware about more about the technology, and they all are aware about the AI and all the things, so that everything which is happening in the world will be very easy for the childrens, and we make our India Atmanirbhar Bharat, self-reliant India. So, with the same, our Prime Minister PM Modi is doing very well in this field, and all the country members who are devoting as a teacher, as a researcher, as in any of the field, who are working as an educator in the field of this, they are doing very well job. So it's our prime duty to uh, can spread the knowledge. Anything else, Gajendra sir, do you want to add? Brijesh sir, are you there? Okay, we will wait for another 1 or 2 minutes. Then we will, uh, I think, very soon our speaker will be joining us.
Hello.
Welcome, sir. Welcome, sir.
Good
We are
morning.
able to
Okay.
hear you.
Yeah. Can you hear me?
Yes, yes, sir. Yes, sir.
Yes,
Okay.
sir.
Thank you. I'm sorry for this glitch. Actually, the thing is that these days there are so many meetings now, and everybody sends a link, and with that link, the software installs so many things in your computer. Okay, and that many times causes problem. So this is what happened with my laptop also. So I have to uninstall it and
No problem,
the
sir. No problem.
previous version and uh, uh, redo this one. Okay, so can we start now?
Yes, sir. Sure, sure.
Okay, so I'm sharing my slides. Okay. Okay, so are you able to see my screen?
Yes, sir, we are able to see your screen.
Okay.
Sir, yes, sir.
So I welcome you all on this lecture on recent trends in robotics. Uh, I'm thankful to Gurukul Kangri University Electrical Engineering Department for inviting me for this lecture, and I hope I will be able to ignite the minds of all those who are going to attend this lecture. Okay, I'm told that Government of India wants to introduce a course on robotics at school level. It's a very welcome step, and usually, our treatment has been for the engineering graduates and seeing their background. So, my presentation, I have tried to make almost no mathematics is there in the presentation, and it will just explore. Or give you an idea on what all new things these days people are working in area of robotics, and especially since last 7 or 8 months after the covid has struck, there is lot of emphasis going on in robotic research. Many new things have come, many new applications of the existing technology has been reinvented. Okay, and people have started using those technologies, as we were not very much used to this WebEx type of meeting, or say Google Meet or Microsoft Teams Meet. Okay, these days there are so many software platform which people are using for the meeting purpose. Okay, so as I was telling you, my lecture will be on recent trends in robotics. So some of the information I've taken from literature, and some of the information is of our own on the topics where our my students are working. Fine. So you might have been given the definition of robot. So I'm just putting initial 2-3 slides just for the sake of completeness, so that I can introduce the topic to you. So a robot is, as you can see, it is an integration of the mechanical, electrical, and software components, and that can be reprogrammed. Okay, why mechanical? Because the physical structure is provided by the mechanical component. Okay, so you have arms are there, or wheels are there, everything, all the physical structure, their velocity, acceleration, all those things are there. So you have the physical structure, the mechanical part. Then these robots are powered, powered, or what we call it as the actuated. So there is electrical actuation. Okay, and are you people comfortable with English, or I can speak in Hindi also?
English only, sir.
English only, sir.
Okay, okay, fine. So,
English is better, sir.
yes?
English is better, sir. English.
Oh, okay, fine. So there are electrical components. For example, the actuators are there, sensors are there. Okay, to sense its own position or to sense the environment. Okay, so mechanical components are there, electrical components are there, and then software components. So software components are basically the one which directs the robot, okay, or the commands which we give what has to be done. So that is with the help of software interface, and these programs are reprogrammable. Okay, that is, you can reprogram these. That is, if you change, you are going to get the if you change the program, you are going to get the different type of task that can be done, and this can be done with and without human intervention. Okay, so you can have the human assistance as well as you need not have the human assistance. Okay, and the topic robotics is basically study about robot design, robot programming, and the robot control. So the first robot came, commercial robot came long back in 1962 by Unimation Incorporation, USA, and this was founded by Joseph F. Engelberger, who is often called as father of robotics. Okay, so this was there, and it was installed in the General Motor plant. You know, General Motors is a car manufacturer company. Okay, and the robots are mostly, or rather the maximum number of robots are used in the car sector, automobile industries. So this was the robot which was the first robot, okay, called Unimate robot. And here you can see the physical structure of it. Okay, it can rotate in this direction, it can rotate in this direction. So these are the 2 degrees of freedom. It can move this way, so this is 3 degrees of freedom. Then the gripper has got 3 degrees of freedom, and here the task of this was to pick the object which are kept in this bin. So you can see there are so many slots available in this bin, and the objects were picked from this bin. So this is the sketch. If you want to explain some of the concept, you cannot do it with the picture of the object. Okay, so we try to explain it using a schematic diagram. So you can see that these are the degrees of freedom of the robot. A vertical motion is provided by this rotation. Then you have a rotary motion provided by this one. Then you have the radial motion provided here, and here you have the wrist bend, wrist swell, and wrist yaw. So 1, 2, 3, 4, 5, and 6. So these are what we call it as the 6th degree of freedom. Okay, so technically speaking, the definition of the degrees of freedom is the number of independent position variables needed to specify the position of an object. Okay, so suppose an object, say an object is there in space. All right, so some object like this is there in space, and say that how many degrees of freedom this object has. So that one can specify how. So you have to take a coordinate system. So a coordinate system can be taken. Okay, and you can have the CG location. So the 3 coordinates you require to represent the CG, that is X, Y, and Z, and the 3 coordinates you require to represent its orientation. Okay, that is, if say there is an a frame attached over here, so how these frames or how these axes are oriented with respect to these axes. So orientation and the 3 positions. So any free body which is there in space, it has got 6 degrees of freedom. Okay, and if you want a object to put at any position, of course in its reach and in any orientation, your robot should also have the 6 degrees of freedom. So the Unimation word, basically it came from the word universal and automation. So you can see uni from the universal and the mation from the automation. So this is how this Unimation name came, and it was because of the belief that robot is a universal tool that can be used for many kind of task. Okay, and most industrial robots of today are designed to work in environment which are not safe and very difficult for the human worker. Now let us look at, when we are looking at the robots, let us look at which are the top 10 countries where highest density of industrial robot workers are found. So many countries are using humanoid robot to work alongside its human employees. So I'll talk a little more about this human robot interaction later in the slides. Okay, so this is there. Over the past 5 years, global industrial robot sales have doubled. In 2019, South Korea has installed 855 industrial robots per 10,000 employees. So if they have 10,000 employees, they have around 855 industrial robots. Okay, and Asia now has a robot density of 118 units per 10,000 workers. So for 10,000 workers, there are 118 number of robots. Statistica listed out top countries with the highest density of robot workers on the basis of the data compiled by International Federation of Robotics. The pace of industrial automation is accelerating across much of the developed world, with 74 installed industrial robots per 10,000 employees globally in 2016. By 2020, the number increased to 113 across the manufacturing sector. Now, here are top 10 countries with highest density of industrial robot installed per 10,000 employees in the manufacturing industry. So now the rank 1 is the South Korea. Industrial robot installed per 10,000 employee are 855. Okay, so you can see a factory environment, factory where industrial robots are used for the different purposes. Then in Japan, industrial robots are installed per 10,000 employees are 364. Okay, and you can see that they have started using the humanoids. Basically, these are the humanoids of the shape of the human, and these people work along with the human being. Okay, so this what they have done in the Japan, and there are many issues. Basically, when a humanoid work with the human, how the human and robot has to interact, they should communicate, they should understand each other. Okay, and the robot should not harm the human also. So all those factors has to be taken care for. Then Germany, it's leader in the car. So the industrial robot installed per 10,000 employee is 364 in Germany, and they use the robot for different type of purposes. Then next is the Sweden, where industrial robot per 10,000 employee are 277. Okay. Then after that, it is the United States, where 228 is the number of robots per 10,000 employees. Italy, these are 212 per 10,000 employees. The industrial robots used. Belgium and Luxembourg, here they are 211. Spain is 191. You can see in the car manufacturing industry how these robots are placed to do a variety of tasks on this, and this is a assembly line basically. Then in China, their industrial robots installed per 10,000 employees are 187. And in France, industrial robot installed per 10,000 employees are 177. This is an example of the warehouse type robot, okay, where the mobile robot is used for shipping or handling of the material. Now, as my today's topic is on the recent trends, so there are many research areas where people are working these days to bring the robots to the market. These are robotic devices and systems, I have already told you. Then I'll talk about autonomous air, sea and undersea and land vehicles. These are there for space exploration and development. We keep on hearing news from NASA where they used this one. Different type of rovers are there for space exploration and development. Then there are intelligent control systems. Intelligent control systems are there. People are working. Then biomimetic modeling, dynamics and control. Biomimetic basically means that we try to mimic the creatures, nature creatures. Okay, so different type of birds, animals, snake. Okay, all those. So mimicking the type of motion these animals have, that is what is called as the biomimetic. And cooperating a robot for manufacturing and assembly, as I have showed you in some of the figures, that is the multiple robot working together for doing a specific task. Then cooperative control of natural and engineered group, identification of dynamic system models, optimal state estimation and control, real-time algorithm for measurement, prediction and control, artificial intelligence, AI and machine learning. Then processing of images, because the camera placed on the robot captures images, videos. So image processing, face and character recognition. Okay, so this is another area where people are working on. Video analysis and manipulation. Then telecommunication network, autonomous and connected vehicles. I'll be talking a little about this. So autonomous and connected vehicles. So connected vehicle means the vehicles are not connected physically, rather the vehicles are connected through say GPS or any other type of device where one vehicle knows the position of the other vehicle. Okay, so that is what is the concept of connected vehicles are there. And autonomous vehicles. All of you must have heard about the Google car, or there are many more cars where people are working to bring the model into the market. Then there are intelligent transportation systems, okay, for the transport purpose. Human factor and human machine interaction, okay. So this is again a very good or very promising area where these days researchers are working, where they try to understand the human factors, okay, the issues with manual labor, basically what should be done so that the persons working in an industrial environment, they do not have tiredness, okay, and how these people can work or interact with the machines. Then human motor control, basically. So one of the robotics research area is also this one, human motor control. Basically, there are, say, some persons or the old age pupil whose nervous system becomes poor because of some reason or other, or they had cardiac attack, and after the attack some of the body functional parts they have stopped working properly. So those parts can be made to work with the help of the robot, okay. So robot can sense the motion, and then or the motion intent can be sensed, and then the robot can be made to complete that motion, okay. Apart from that, the robot can also be used for teaching purpose for these type of persons, those who are having, say, writing problem or not able to write properly, okay. So those type of person can be trained or to have their nerves control, okay, or the human motor control. Then there is another area is the modeling perception. How do we model the perception? Perception is, how one conceives others, or one knows the opinion or one's opinion about somebody else, okay. So that is what is the perception. So can something be done to model the perception? Then the neural network modeling of cognitive functions, reinforcement learning, study of the brain function using functional magnetic response imaging, electrical and the optical methods. Then, as I told you that the actuators and sensors, they are very prominently used in robotics. Actuators are used to give the motion to the robot. Okay, so for different type of robots which are used at different places, so people are working on the developing the different type of actuators. For example, if you are using some robot for the surgery purpose, you require very minute actuators, okay. So those type of work is going on. And similarly, the sensor technology, development of sensors for sensing the external world as well as the structure of the robot own sensing. Then the biorobotics and bioinstrumentation, that control of complex systems is there, precision instrumentation is there, autonomous robotic vehicle and optics is there, deep learning for robotics is there, human robot interaction I just talked, robot and exoskeleton. This is again another one of the very important area. Legged robot and exoskeleton. Legged robot means your say four-legged robot or two-legged. Two-legged means the sorry humanoid. We have already I just talked a little about them. So humanoids are there. Those are the two-legged animals, or you can have the four-legged animals like say cow are there, yeah, or horse is there. Okay. So what type of
Sir, can you
motion?
explain biorobotic? Can you explain, sir, biorobotic?
Yeah, biorobotic, as I said, it's basically mimicking the biological creatures, basically. Okay, that is the biorobotics. All right,
Thank you so much, sir. Thank you.
biological creatures. Yes. Then the legged, as I said, exoskeleton is again what is going in exoskeleton is that suppose there is a person, there is a woman is there, and individual is there. All right. Now what happens if this person, say this person can carry a load of say 20 kg, 25 kg, okay, with him. Right. Now, suppose this person has to climb the hills. All right. Then naturally, carrying that much load on his say shoulder will be a very tiring for him. And so, what people have done is that they have developed a robot, wearable robot, which we call it as a exoskeleton, and that can be weared by this person. Okay, and now these robots have got the motors. Basically they have the power pack here, and they have got the motors. So they have power pack or batteries here. These motors can be actuated by the batteries, and so the effort required by this person to carry the load, that reduces. Okay, so that is what is the concept of exoskeleton, and this concept is very much useful, especially for the soldiers. Actually, soldiers has to carry very large amount of payloads. Okay, so the concept is very much useful for the soldiers. So defense establishments are working this in this area. Then you have the manufacturing robots, as I've shown you in some of the slides earlier. Motion planning, how the robot has to move, or the how robot moves, that planning. Then the rehabilitation robotics, as I told you, that if some stroke comes to a person, then some of the body parts becomes unfunctional, so the person has to be rehabilitated. Okay, so the robots are used for that purpose. Then robot perception and manipulation, talk about it. Then robot teams and swarms. Okay, there is a word called swarm robotics, basically. So swarm is a word which has come from the bees. Basically, you see, bees, there are number of bees, and they move together to when they move from one place to another place, they move together. So the swarm robotics concept is that there are many such types of robot, small robots, and they these robot communicate with each other. Okay, and they move together to perform a specific type of task. So that is what we call as the swarm robotics. Okay. Then another very important concept in which people work is that SLAM, what we call it as the simultaneous localization and mapping. Okay, suppose a robot is here, then if we are seeing that, then we can say that okay, robot is here. But how does the robot knows where it is? Okay, so robot should know where it is with respect to some reference. Okay, so that is what is called as the simultaneous location of the robot, localization of the robot, and mapping of the environment from which in which the robot is there. So here is the work which I was telling you about. So the first one is the mobile robot. This is named as Robotino, which is a German company. Okay, so it's used for search and rescue, remote control. Robust method is there. Then there are walking and robots. So this is a big dog basically. You can see in the YouTube there are very popular videos by the same group called Boston Dynamics, the company which make type of robots. And this robot was designed for carrying the large payload for the helping the soldiers. And this robot is powered by internal combustion engines. Internal combustion engines means the engines which are say used in your say motorcycle. Okay, so that type of engine has been put into to power this, and it has got that type of motion. And you see that the legged robot, they can move in uneven terrain, and also they help us to understand the biological locomotion. Okay, how these animal, or how the biological animals move basically. Okay, for example, when they walk slowly, they have one type of gait. When they run, they have another type of gait. Then there is area, what we call it as the space robotics. Okay, here in this figure you can see a basically, and these are the solar panel for powering the satellite. And suppose this part is something separate part, and this part has to be integrated to this one. One can have the robot like this, and this robot can pull this and integrate it into this satellite. Okay, so this type of job are done by the space robots. Okay, and these are the tele operated, that is the remotely operated. This picture shows you the Dexter, a two robot which was developed by Canada's space agency. Okay, so this is the first arm, and this is the second arm, and these two arm robot can be used to do a variety of tasks. Okay, and here is the different type of systems which it has. Say camera and light system is there, hand tool and grippers are there, force moment sensors are there to measure the forces and moments. Okay, there is a tool holder. So there are many more devices. So these type of robots, what we call it as the space robot, and these are used in the space. Then there are robots which are used in the underwater. Okay, you see, these robots are difficult to control in the sense that if something is there in space, you don't have the inertial frame, to take the reactions. Okay, so that is one of the major challenge in the space and the underwater robot. So here you can see the underwater robot. So this is the gripper over here. You have a camera, sensors. Okay, you have a propeller here to move it forward. All right. So and this can be used for the underwater investigations. Then, after talking about all this, let us see in last 10 years how the robotics has evolved. Last 10 years. So the driverless cars, as all of us know, they are not yet into market, but say in San Francisco, a company has got the license to test these driverless car. So next 5 to 10 years, we can see such cars in the market. Okay, so these all are the developments of last decade. Then you have the e-commerce robots, these Amazon, Flipkart, whatever things we are ordering, and we are getting them so quickly after the order. Okay, so warehouses are equipped with robots to do the task, various type of tasks. I will be talking about them. And then the robots are used for that purpose. Then you see the surgical robots which are used for surgery. Till now, there is a robot called Da Vinci, which is only the one which is available in the market and used by many hospitals for surgical procedures. Okay, but it is expected that in near future there are going to be many more such robots are going to come, which can help the surgeons in performing the surgery. Then there are safety and security robots are there, robots for disposal of explosive material, bombs. Okay, all those things are there. Then human computer interaction. So design the industrial robot which I showed you in my earlier slides, that technology has matured and now it is very well used in many industries. Okay, so these are the some of the recent technologies which people are exploring and they are trying to bring it to the market. So I was talking about human computer interaction. So this is basically designing robots that are human friendly and easy to work with. Okay, so a robot and a person both can work together and do a desired task. Then you have the natural language processing. Okay, so these are software focused, involves getting a robot to understand the human speech. Okay, that is the natural language processing. I'll be showing some work we have also done, so I'll be showing that. Then there are machine learning. It involves getting a robot to understand a definite pattern, basically. Okay, and that is done with the help of machine learning. And then there are soft robot, designing robots that are skissy. So that is also there. I'll be talking about it. So first of all, let us see the driverless car. So a self-driving car, also known as autonomous vehicle, connected and autonomous vehicle, driverless car. Basically, there are many names for. Okay, automated vehicle and fully automated vehicle in the European Union, they are called. Okay, is a vehicle that is capable of sensing its environment and moving safely with little or no human input. Okay, so this is the definition which I have taken from the wiki. So that is there. Okay, so this is basically the self-driving car. And how does they do it? They do it by combining the variety of sensors in order to perceive their surrounding, to understand the surroundings, such as radar is there, lidar is there, sonar is there, GPS is there, odometry is there, and inertial measurement units are there. So with the help of integration of all these type of sensors, driverless cars are able to work. There is advanced control system that interprets sensory information to identify appropriate navigation path as well as obstacles and relevant signage. Okay, so all these things are then connected vehicle platoons and long distance trucking are seen as being the forefront of adopting and implementing this technology. So here is a computer generated image of the driverless car. So here you can see that there is a central computer over here, and here are the sensors. Basically, there is radar sensor, there is video camera, there is lidar, that is light detection and ranging. There is global positioning system, GPS into it. There is a rear camera, ultrasonic sensors, and the odometry sensors. So all these sensors information is sent to your computer over here, and based on these information, computer takes the decision for the motion of the car. Somebody has unmuted his transmitter.
All the participants are kindly requested to mute themselves.
Okay. Next, as I was talking about, these e-commerce robots are used, say, by Amazon, Walmart, or other online clothing store. And what job they do? They do job of stocking, sorting, packing, unpacking, labeling, scanning. These are some of the jobs which are done with the help of robots. And not only the shipping company also, once they are packed from here, the shipping company also use robot to sort packages and route them to the correct path. Okay, and these days you see these companies have distributed. Earlier there used to be a central warehouse from where they used to supply this, but these days they have distributed their centers. Warehouses has been distributed, made as a closer proximity to the users, and the orders are fulfilled from there. Okay, so they are using the e-commerce robot for this purpose. And as I said, innovations are going on constantly, and things are evolving this way. Okay, so this is you can see one of the Amazon warehouse, where you can see the number of robots, as you can see here. Okay, so all these are the robots, and these robots are used to take the items from one place to another place. Then not only that, they move, they can pick up the items also. They can have an arm over here, and they can pick up the correct labeled items from these bins, and then those items can be moved. So this is what all work has done in the last decade. The surgical robots, as I was telling you, these are the medical robot, teleoperated. So you can see this end effector. This is how this replication of the human fingers, and they are used in the robotic surgery. And this is the Da Vinci basically, okay, and which is used for the surgical process. And this is how it is there used. So you have the robot here your patient lies here, and here is a computer console from where the surgeon controls this robot for the surgical procedure to be carried out. Here technicians are there to change the various tools which are used for doing the surgery. Yeah, this the natural language processing. This is the robot which we have developed in our lab at IIT Roorkee with the input from the Max Hospital Dehradun. So they came with a request that due to COVID they want a robot to be developed at there. So we have developed this robot. Then just have a look at. And this is the purpose of this robot is that they wanted that the patients, those who are coming, so those who are having fever, they should be segregated with the other type of patients. Okay, so and there should be provision for registration of the patients, so that they can keep track of, and the robot should be able to take the temperature. So this is the robot which we have developed, and this is currently at the final testing phase. I'll just like you to show this. Is it audible?
No, sir.
No, sir.
Are you not able to see the listen the audio? Can you see the video?
We can see the video but unable to listen the audio.
Okay. So so it asks for the address, it asks for the mobile number, it asks for the name, and then it takes the temperature.
Sorry to disturb in between. So actually we are not able to enlarge the screen. Can you do that? Because it is so small in this.
Screen not able to enlarge.
Yes, sir. Very small screen is visible. We are not able to read anything visible on
Is
the
it? Okay.
No, ma'am, there are two arrows below the PowerPoint screen. You just click on them, the video of sir will get heightened and you'll be able to see the PowerPoint presentation on the whole screen.
right now. Actually, I'm working on phone.
Yeah, even I am doing it on phone only. It's working, ma'am. Please try it.
On which side, ma'am? On left side or right?
Yes, it is working.
On the left side, just below the PowerPoint screen, there are two arrows, one towards up and the other one towards the down.
Okay, let me check now.
Okay. So this is how it does. And as I said, this robot is under testing phase at IIT Roorkee, and we hope to see this soon in the Max Hospital, Dehradun. Okay. Next is about the soft robot. Okay. So as you can see the name soft, this basically tells you that something which is compliance, which has got compliance basically. Okay. And these robot exhibit large strain in the normal operation. And here I can just quickly explain you the capabilities of hard and soft robots. Basically, if the hard robot which we have seen earlier, they have got the rigid links, and suppose if this is the obstacle, then if your joint rotates here, then it's likely that this is to hit the obstacle. But in case of soft robots, you can see that it can deform, bend, and it can easily avoid the obstacle. So this is the advantage of it. Okay, another advantage is about gripping. So if the hard robot has to grip a object, it has to be do like this, but a soft robot can be gripped in this way, that is which is more a better way of gripping the object. But there is a problem of sensing and loading. Sensing problem is that in case of hard robots, we use the joint sensors, and these sensors can sense these joint rotations very easily. That is with the help of, say, potentiometer or encoders or uh, other measuring device. But in case of soft robots, actually these length have to be measured basically. Okay, and that is a little problem. All right. So that is one of the issue. Although people are trying to do it with the help of linear potentiometers, but still that is a problem. And then loading in soft robot, there is deformation basically in the robot, and because of that, it is difficult for the robot to be there at the exact position. Whereas hard robot also, this because of loading, some deflection is there, but that is manageable. Here are the example of the soft robots, say the tongue of the dog, or say the elephant trunk. Okay, it's a soft robot basically. There are other bionic robots, for example, say the flying bird. Okay, the one which you might have seen in the Uri movie. Okay, so this is the robot basically which I have shown in the picture, made by the Festo company, and there could be the robot muscles basically. You can see that these are the muscles basically, the pneumatic actuators, okay, which provide strength to the muscles, and with the help of these muscles, these fingers can be actuated. Okay, so this is the bionic one basically. So animal like robot, they can use to explore unknown planet, work in hazardous environment. They can have a home robot, toys, artistic, and so on. So this is the basically the soft robot which I was talking. Yes. Okay. Anything anybody wants to say? Okay. This is the bionic manipulator. Basically, there are 6 segments here: 1, 2, 3, 4, 5 over here, and these are pneumatically actuated. And yes, they can handle the different type of objects. No. So this video maybe it is not working. So this is the CAD model of that. Here are the solenoid valves basically. No, it is not working. Okay. No, I'm sorry, these videos are not working actually. I can show them directly. Are you able to see the video? Yes?
Sir. Yes, sir. Sir, it's visible.
Yes, sir. Yes, sir.
Sound we can hear.
Yeah, so this is how these soft robots are there. You can see the wheels over here, and these are the potentiometer wires which I was talking to you. This is how the tubes are made basically. This is the gripper. Okay. Okay, so this is how these bots are used. Then we can have the cooperative motion planning of these bots with the help of two such robots. Okay, say an object is being handled by say left and right robot together. So that can be done. Next is we are going to talk about another type of robot, that is what is called the snake one. Okay, the biomimic. Why biomimic a snake behavior? Okay, so due to their elongated form and lack of legs, snake have compact cross section and thus can move through very thin holes and gaps. So that is the advantage the snakes have, and they have ability to climb up and over obstacles that are much taller than their body height. That is also there, and their gaits are very stable due to the constant contact of the body with the ground at different points. Okay, because of this, that is there. So there are four common and distinct gait. Gait basically means the way they move. Okay, so there are four common and distinct gait that snake normally use in tail movement. These are the serpentine, that is the lateral undulation, then concertina, side winding, rectilinear progression. Okay, these are the four types, and most snakes are capable to execute all or several of these locomotion. Okay, and generally switch as per the requirement. So they can perform all type of motion, and they can switch, like we walk and when we desire we run. Okay, and there are different type of gaits for that. Okay, so likewise snake can also switch and change their gait. In some situation it may even use a combination of more than one gait. So serpentine motion is basically S-shaped movement, also known as lateral undulation, is used by most snake on land and in water. Okay, so that is the serpentine motion that you can see. And here on the land, a snake usually find resistance point in the surface, such as rocks, branch, or dent, and uses its scale to push or point all at once, thrusting the snake forward, as you can see here. Okay, so this is how the snake moves in the serpentine motion. Then there is what we call it as the side winding. Okay, so side winding, as you can see here. Okay, this is how they do it. In the environment with few resistance points, snake may use a variation of serpentine motion to get around. Okay, and contracting their muscles and flinging their bodies, sidewinder can create a shape, and that has only 2 points of contact with the ground. When they push, they move laterally. Okay, so they move laterally basically. That is why their name is side winding. Much of the side winding snake body is off the ground while it moves. Then yeah, side winding or rolling movement. This has been explained a little more here. Then you have the caterpillar type of, you can see here the caterpillar. Okay, that is this one, the rectilinear motion, the last one in this figure. Okay, so it is a much slower method of movement, is caterpillar or rectilinear motion. This technique also contracts the body into the curve form. Okay, but these waves are much smaller and curves up and down rather than side to side. So it up down, as you can see in this figure. That is there. There is not much the side motion is there in this case. So this is how you can see these are the point of support from where the snake gets the reactions, and then it moves. Then there is a gate concertia. In this one, the snake extends its head and the front of its body, okay, along the vertical surface, and then finds a place to grip with its ventral scale. All right. So that is how it does. To get a good hold, it bunches up the middle of its body, as you can see here. It bunches up the middle of its body, as you can see here, okay, into tight curves that grips the surface while it pulls its back and up, okay, and then it moves forward. So this is how we try to implement this type of gate here. You can see the caterpillar motion or rectilinear motion. This is how it moves. Okay. This is the side winding where it moves forward by moving in the side, and this is the lateral undulation type of gate is there. And many times to design these robots, we do some simulation activity, write the mathematical expressions for the robot, create a model, and then do the simulation. Okay, I'm sorry, this probably will not move. Yeah, so that we do. And this one figure you are seeing this video, this is again a snake robot, and this is a bionic one that is this is pneumatically actuated, different type of is pneumatic actuation is there. It's wireless, okay, and we are in the process of patenting this design. The earlier one, which videos I showed, those were actually the electrical motors were used here. Here we are using a pump basically to create it. Okay. After this, there are let quickly tell you about 5 exciting type of robotics research. Emergency assistance robot, for example, if there is fire in a building, so can there be a robot which can evacuate the persons. Then the home robots, okay, lot of homework has to be done by the housewives. Okay, so can there be some robots to assist that? Then the gaming robots for the children to play the games. Knowledge sharing robots, can we teach a robot and then the robot can teach the other persons? That is what is the knowledge sharing robot. Okay, so these are other areas these robots are there. So emergency assistant robot, focus on developing a robot for the emergency assistance. They can assist people in disaster recovery, perform rescue mission in hazardous condition. Okay, simply go to the places human cannot go. Mars rover, we know that. Then a rover robot built to explore extraterrestrial terrain and search for sign of habitability. Okay, so all these are there. Can I continue for 5 more minutes?
Yes, sir. Yes, sir.
Sure.
This robot which you are seeing, This is
Yes, sir, you can.
Okay. This is Daksha, developed by DRDO. We did some modeling work for them. So here you have a mobile base, as you can see, and on this mobile base, this robot is placed. Okay, and this robot is currently used by the defense forces and many police organizations for the disposal of the bomb. Actually, okay. Then this DRDO Netra unmanned aerial vehicle is there. This was used very much during the Uttarakhand tragedy, which was there few years back. So there were a lot of flooding and that, and so identification of the persons, this was used. So this is a Netra which was there. This is Curiosity rover for Mars exploration. It's a computer image of that. Okay, that was there. Then the home robot, as I was telling you, there are many work going on for the home robot. We are also doing some work in that. Okay, so these robots are developed for consumer convenience. Okay, they are programmed to help people with everyday tasks. For example, cleaning a home without human supervision. So Nito D7 is the latest vacuum robot that has embedded sensors to help map the layout of home. It can map the layout on home. It can remember where not to go and the area which already has been cleaned so that it need not repeat that. Okay. That is Nito D7, and there is more room for improvement. How home robot learn about and responds to their environment. Okay. Uh, MIT Media Lab has a personal robot group that specializes on the human robot interaction. And one of their goal is to create robot to help children learn, assist kids in hospital, and facilitate parent-teacher interaction. This is the robotic vacuum cleaner, which is available in the market, made by and which can be used for the cleaning of your house. Then, as I was talking about the gaming robot, see, gaming is a big industry actually. Okay, and one of the industry leader is the DeepMind, whose mission is to develop robot that can learn to solve problem autonomously. Okay, so DeepMind robots thinking abilities are self-taught, and an example, company's AlphaGo robot is programmed to play Chinese strategy board game called Go, which involves obtaining territory. So there are gaming robots. Then, as I was telling you, the knowledge sharing robots, a newer trend in artificial intelligence is the knowledge sharing. And robots are highly sophisticated learners that can also be programmed to teach other robots as well. Okay, and so learning from another robot is faster than learning alone. Okay, so this is what is there in the knowledge sharing robot. Researchers at Brown University, they are piloting this knowledge sharing effort and also work on how to improve robots' learning ability, such as improvising the software that enables robot to fine-tune their actions. Okay, so I think with this, I would just like to conclude my lecture. Okay, there are new robots skill which are coming. There are areas, artificial intelligence, which are of course going to help the robotics a lot, and these are promising agents for emergency hazardous situation. Exciting field for those who want to pursue the artificial intelligence. You can see the application of artificial intelligence in this. These are some of the references which you can see. Some mathematics you can find in our book on intelligent mechatronic system, which is published by Springer. Thank you. Thank you for your time. Thank you for the patient hearing.
Thank you so much, sir, for such a wonderful session. Now, I would like to call Mr. Yogesh Kumar for the vote of thanks. Mr. Yogesh, are you there?
Hello.
Yes, sir. Yes, sir.
Mechanical IIT tells about the recent trends in robotics.
योगेश जी लाउडली बोलो, आवाज नहीं आ रही है.
Definitions of robot. First robot, commercial robot, comes in 1965, and DOF, degree of freedom, animation, universal 2. There tells us about the research areas like robotics, devices and system, autonomous air, industry, intelligent control system, AI, artificial intelligence and machine learning, video analysis and manipulation, human motor control, like modeling, perception, neural network, modeling, control of complex system, and motion planning, manufacturing, mobile robots, search and rescue, remote controlled robust space robots. It tells about the space shuttle, some surgical robots or natural language process soft robot. Thanks to Dr. P. Pathak sir and to the participants.
Okay. Thank you, sir. Thank you so much, Dr. Pathak, for giving us such an insightful session. Thank you so much, sir.